Okay, page 5 and 6 of vectors. Remember that a scalar is kind of the opposite of a vector. A scalar has magnitude, but no direction. Okay. We can multiply vectors by a scalar k, and k can be any real number. Okay, it can be like a decimal, it can be irrational, it could be like pi, for example. Okay, as long as it's real. If vector A is this vector here, then draw 2a, 3a, and negative 3a. Okay, and so since we have the wonder of technology here, we can like do things like this. See there, I drew 2a. Let me draw 3a. Is that cheating? There's 3a. What about minus 3a? Ah, minus 3a. There we go. There's minus 3a. Okay? Page 285 reading. What if you multiply a vector by a scalar k equals 0? If you multiply a vector, any vector by the scalar k equals 0, guess what? You get the 0 vector. You get the 0 vector. Given vectors r and s, construct geometrically minus r. Okay, minus r would just be that, right? 2r minus s. So 2r would be, let's see, would be over 2 up 3 over 2 up 3. That would be 1r, 2r, minus s. Minus s would be the opposite, right, of that one. So, oh, you know what? I wanted to draw these with a different color because red to me kind of means negative. So let me do this again. So 2r would be 1, 2, and then minus s would be like that. So the resultant vector of 2r minus s would be the orange one here. What about 1/2 r? 1/2 r. So that would be halfway, like that. 1/2 r. What about 1/2 r plus 2s? Okay, so we'll have 1/2 r, and then 2s would be, let's see, s is like 2 down and 3 across. 2 down and 3 across. Like that. So it would be about like that. Let me put the whole thing like that. So the resultant vector would be like that. Okay? Alright. Sketch vectors p and q if p is equal to q, if p is equal to 2q, and p is equal to negative 3q. So if p is equal to q, then like p, that would be p, and then this would be q. What if p is equal to 2q? Okay, so then I would have p, and then I would have q would be one of these. Okay. P is equal to negative 3q. Okay, so let's say p is equal to that. And then q would be like 1/3 of that. So if I multiplied q by negative 3, then it would be 3 times as long, and it would be as long as red, and it would be in the opposite direction. So let's see. I made it a little bit too long, I think. It should be like a third of the length. Okay? Alright. 3a. Copy this diagram and on it mark the points x such that mx equals mn plus mp. Let's see. X such that mx equals mn plus mp. Okay, well, let's figure out what's mn. Mn plus mp. mp is that one. So mp is 3 back and 3. So 3 to the left and 3 up. So that's mp. So mn plus mp is supposedly equal to mx. So x is right there. Okay, and y such that my is equal to mn minus mp. Mn minus mp would, mp, the negative of mp is like that, right? So this would be minus mp. And in this case, my is like that, so y would be that. And mark z such that pz equals 2 pm. Pz equals 2 pm. Where's pm? Okay, pm. So pm is actually, you know, like this direction, pm. So pm plus pm would be pm plus pm. And pz, mark z such that pz, okay, so this would be z here. Okay, so we marked our z, we marked our y, and we marked our x. What type of figure is, oh, they're going to make a figure out of this. Mn, yz. Looks like a parallelogram. Yeah. We'll write parallelogram. Parallelogram. Okay? ABCD is a square. Its diagonals AC and BD intersect at M. Okay, so they're telling us where M is. If we intersect those, M is right in the middle. If AB equals P and BC equals Q, find in terms of P and Q, CD and AM. Let's see, CD and AM. CD and AM. Let's see, CD in terms of P and Q. So I would say it looks exactly like P, except it's in the wrong direction. So we'll just make it negative P, right? What about AM? AM doesn't look like P or Q. It looks very much smaller. But what if we took like maybe half of P and we took half of Q, then we would get to the same place as AM. So let's do that. We'll do half of P added to half of Q. Okay, I think that works. All right, page 6. I will do page 6 in the next video.